For this group of problem that picks up off of the two-step equations from equations. However, there is going to be a trick if you ever have to multiply or divide by a negative, and we'll see that starting in number 10. As always, if any of this stuff is too difficult for you, or you don't remember it from equations, the last unit, hit pause and call a teacher over, and we'll be happy to help. So the problem we have in front of us, we have a two-step equation. Remember, with two-step equations, you want to chip away from the outside, meaning things that are further away from the variable. So you have 3y minus 1. What's furthest away from the y is that minus 1, so that's what you want to move first. So you're going to add 1 to both sides of the equation. Sorry, the inequality. The 1's cancel. You have 3y is greater than or equal to 17 plus 1 is 18. The second step is going to be to divide both sides of the inequality by 3. And you're left with y is greater than or equal to 6. So we're going to locate 6 on the number line. It's greater than or equal to, so it's going to be a solid dot at 6. And it's greater than, so you're going to go to the right. Now for this problem, you get a couple different steps. You're going to adding negative 5 and you're dividing by 4. So you want to work from what's furthest away from G first. So you're adding negative 5, which is kind of like subtracting 5. So I'm going to add 5 to both sides of this inequality. 5's cancel. I'm left with G over 4 is less than 3. Now I'm dividing by 4. How do I undo divide 4? I multiply by 4 on both sides. The 4's cancel. And you're left with G is less than 12. So I'm going to set up my number line. I'm going to find 12 on the number line. It is a less than, so that's going to be an open point or open dot. If it's less than, I'm going to go to the left. Number 9 is a two-step equation an inequality. It's an inequality because it has an inequality sign. That less than or greater than are inequality symbols. It's an equation if you have an equal sign. So this inequality is a little bit different. The variable is on the right. So eventually we're going to have to flip everything. But for right now, we're going to subtract 18 from both sides. That's what's furthest away from the variable p. The 18's cancel. 12 minus 18 is negative 6. We have a greater than 8p. Okay, so the next thing to go is at 8. 8's being multiplied, so you're going to have to divide it on both sides. But now we're going to come into a little bit of a problem. You're going to have negative 6/8 is greater than, those cancel, so p. Okay, well, negative 6/8 I can simplify. That's negative 3/4. So I have p, I have negative 3/4, and I want to mirror the whole thing. So the symbol is opening up towards the fraction, negative 6/8, which is equivalent to negative 3/4. So I need to do that on the right, on the other one as well when I mirror it. Okay, so negative 3/4, I believe we've done this one in the last section, but that is between negative 1 and 0. In fact, it's 3/4 of the way to negative 1. So I am going to put an open dot at negative 3/4. Closer to negative 1 than to 0. And since it's less than, I'm going to shade to the left. So number 10 is the problem where the extra rule comes in. But the extra rule only happens in the second step. So for this one, you have h being divided by negative 2. It's also being added by 7. Well, plus 7 is further away from the h in terms of order of operations. So I'm going to take care of that first. In order to undo plus 7, I'm going to subtract 7 on both sides. 7's cancel. I have h over negative 2 is less than or equal to 6. Okay, so now I need to undo divide by negative 2. So that's multiply by negative 2. But now you have the big rule. The big rule with inequalities is that if you multiply or divide by a negative number, you flip the inequality symbol. Let me show you what I mean by that. The negative 2's cancel. I'm left with an h. 6 times, that should be negative 2. 6 times negative 2 is negative 12. Okay, that inequality symbol was a less than or equal to. Now it's greater than or equal to. I had to flip the inequality because I was multiplying or dividing. In this case, I was multiplying by a negative number. If you want to see a proof of this or another explanation, hit pause and call a teacher over now. You might have seen this before in your past years, but if you haven't, call someone over right now and they'll be happy to explain it to you. If not, wait until the very end of this video and I'll explain why you flip an inequality. So from here though, you need to label your number line and plot this. So I'm going to go negative 13, negative 12, negative 11. Alright, so it's going to be or equal to, so that's going to be a shade in point. And it is greater than, so I'm going to go to the right. Our number 11 is a two-step inequality, but you are also going to have to flip the sign. So that 12 is further away. Now be careful, that 12 is positive. I know there's a subtraction sign between the 12 and the 5y. Sorry, the 5w. But the 5w is what's negative, not the 12. You could write that as negative 5w plus 12 if you really wanted to. Actually, why don't we do that off to the side? Negative 5w plus 12. It's the same exact thing as what I have on the left of that. My thought bubble. Okay, so if you were to undo that, you would subtract 12 from both sides. And that's what I need to do here. So subtract 12 from both sides. 12 minus 12 is 0, so you can see it cancels out. Make sure that negative sign comes down with the 5y. So it's negative 5, sorry, w. Negative 5w is less than 10. Okay, so now you need to divide out by negative 5. The negative 5's cancel. You have w. 10 divided by negative 5 is negative 2. But now I need to flip that inequality. So now it becomes w is greater than negative 2. So I'm going to set up my number line. I'm going to say it's an open circle, open dot, open point, because it's just strictly greater than. And since it's greater than, I am going to shade to the right. Okay, this is another two-step inequality. The furthest thing away from p in terms of order operations is that minus 6, so I'm going to add 6 to both sides. The 6's cancel. I'm left with 1/3 p is greater than or equal to 8. So how do I get rid of that 1/3 p? There's a couple of different ideas we can have. First of all, you want to divide by 1/3? Sure. Dividing by 1/3 is the same thing as multiplying by 3 over 1, which is the same thing as multiplying by 3. So that's one thought. So multiply by 3 looks to be the same, what I can do to undo that times 1/3. Another thing you can say is, okay, 1/3 p, well, multiply 1/3 times p. That's like saying multiplying 1/3 times p over 1. Multiply across, you have p over 3. So how do you undo p divided by 3? You'd multiply by 3. So either way you look at it, it's the same thought. You're going to multiply both sides by 3 to get rid of the 1/3 p. So those cancel. You're left with p is greater than or equal to 24. So I'm going to set up 23, 24, 25. It's greater than or equal to, so it's going to be a color in dot at 24. And since it's greater than, you can go to the right. Alright, so let's take a look at why when we divide or multiply by a negative do we flip the inequality. So let's just say I have negative x is greater than 6. Okay, and we want to know if that's going to be the equivalent of, well, let's think about it. If we're going to do the rule, that's going to be divided by negative 1, divided by negative 1. Also multiply by negative 1. Either way, negative x divided by negative 1 is going to just be positive x. that's 6 divided by negative 1 is negative 6. You'd have x is less than negative 6. So we know by our rule that that is what we should end up with. So I divided each side by negative 1 to get rid of the negative sign. I could have multiplied by negative 1. You know what, let's do one more of these problems just to show that that rule is going to stay the same. Let's go negative 2x is greater than or equal to 12. Okay, and I'm going to divide each side by negative 2. This might be a little bit easier to look at because you're not using that weird just dividing by negative 1. Okay, so by our rule, these cancel. I'm left with x is, got to flip the inequality, less than or equal to negative 6. Okay, so for each one of these problems, I want to redo it by a different way. Okay, so negative x is greater than 6. What if I added x to both sides? So these cancel out. I'm left with 0. It's greater than 6 plus x. Okay. What if I subtracted 6 from both sides? 0 minus 6, negative 6, is greater than x. Now if I want to mirror this over to have the x on the left side, that's x is less than negative 6. So that's the same thing as on the left. Let's do that again with the blue problem. Negative 2x is greater than or equal to 12. If I were to add 2x to both sides, well, that'd be 0 is greater than or equal to 12 plus 2x. I could then subtract 12 from both sides. I would have negative 12 greater than or equal to 2x. Could divide 2 by both sides. And I would have negative 6 is greater than or equal to x, which I could mirror over as saying x is less than or equal to negative 6. So again, I have the same thing. So that's just a demonstration as to why that rule works. These problems I just did were not from your note packet. However, it explains to you why when you divide or multiply by negative that you in fact do need to flip the inequality symbol.